Hi, I'm Aaron Yee, Head of Product Marketing at Anjuna Security. Today I'll talk about a compelling innovation in data security called confidential computing, and how Anjuna uniquely helps customers secure the public cloud with it. And we'll see a demo. But first, some context. As you know, data can be in three states: at rest, in motion, and in use. Today we can secure the first two with encryption, but protecting data in use is a little trickier because applications need clear text data in memory where it is vulnerable to exfiltration by anyone with server access. Fortunately, there's a breakthrough in security that protects data in use called confidential computing. Intel and AMD introduced it into CPUs, and AWS, Azure, and GCP made it widely available. It uses hardware-grade memory encryption or isolation to provide privacy for your data. You can now migrate sensitive workloads to the cloud without worrying about bad actors or even cloud provider staff eavesdropping or tampering with it. This sounds promising, but there's a catch. It's very difficult to directly use confidential computing offerings. You have to refactor and recode your applications without degrading performance, and that's a challenge for developers. Also, the chip makers and cloud providers each implement it a little differently, so if you want to deploy your app to multiple clouds, you have to refactor and recode yet again. That's where Anjuna shines. Instead of doing all that engineering work, simply launch your app with one binary from Anjuna. We run your app in a secure enclave and handle the hardware level calls to deliver full-speed confidential computing without the headaches. It's a lift and shift approach. Anjuna is the only provider that works with the latest confidential chipsets from Intel, AMD, AWS Nitro, and NVIDIA. Anjuna works on virtual machines, containers, and even bare metal servers, so that's a lot of flexibility. The benefits are pretty far-reaching. You can migrate workloads to the cloud, you can reduce your attack surface, you can meet compliance requirements for protecting PII, you can foster customer trust by keeping their data private in the event of a breach. Let's see a demo.
Hello, my name is Dominic Egger, and I'm a Principal Architect at Anjuna Security. One of the things that we specifically focus on to show customers a better way of securing applications is by showing them what it could look like if you didn't have Secure Enclaves technology. And today what we're going to be doing is running a Redis service in a non-secure environment, showing you how easy it is to exfiltrate information. So what I'm going to do here is I'm going to run the Redis service. I'm going to put in some PII information. I'm going to grep the process, and then I'm going to exfiltrate that information. And as you can tell, when I go ahead and look at the memory dump, this can easily show how fast we can exfiltrate the information from an in-memory process. With Redis, it stores everything in memory and then commits later to disk. So I'm going to go ahead and stop the process. It's going to commit those changes in a disk, and I'm going to see what I can look at from a file system perspective. So you're going to see right here that in JSON format, I can actually grab the PII information from the disk. And even if I didn't have that format, I can still look at the personal identifiable information, specifically in the binary itself. So we're going to go ahead and change this demo a little bit. I'm going to go ahead and remove that database that we just created. And I'm going to run Redis in Anjuna runtime engine. And we're going to do the exact same thing we just did. I'm going to go ahead and put the PI information in the mix. I'm going to grep for the process. And I'm going to go ahead and do a memory dump. This memory dump is going to basically show me if I can actually pull from in-memory, and as you can tell here, we could not pull from the in-memory process. The main reason why we couldn't pull from that is because Anjuna's runtime engine separates the user space and the applicant space so that we can easily protect what's actually being in use. And so we're going to go ahead and do the exact same information. We're going to go ahead and save that to disk. And when I go ahead and view that database as a whole, you can see that we actually encrypted the file so that only the Anjuna runtime engine can view that specific information. And this is actually being protected with AES 256. And with that being said, thank you for your time, and I hope find this demo actually works great for you to understand how our technology works.
That was pretty neat, right? Your infrastructure, VM, or root accounts can get completely breached and your data will be safe. This exciting tech will drive change in our industry for years to come. Anjuna simplifies confidential computing and makes it accessible to people. Thank you for watching.